The midterm review continued. I'm going to start with number four. And number four basically says a 45-year-old worker is injured and will not be able to work. Assume that she would have earned an income stream of this much dollars per year for the next 20 years using a continuously compounded prevailing interest of 5% and the correct lump sum of money that would replace all of these future earnings. So basically, I looked it up and lump sum just refers to present value. So we use the present value formula, which I wrote right here. And yeah, we have the income stream is equal to T is equal to 100 plus T. And then we also have the prevailing interest rate. So it's going to be a rate of is 0.05. So this is the information that we need. Our part now is calculating it. So we want it from 0 to 20 years. 100 plus t times e to the negative 0.05 dt. Okay, so this is the integral, and it is an integration by parts. So we want to start off by doing the integration by parts. So I'll let u equal to 100 plus t. EU is equal to 1 dt. EV is equal to e to the negative 0.05 t, and v is equal to um negative 0.05 t over 5. And this is from a u substitution. And now to set up the actual integral, you want to do 100 plus t times negative e to the negative 0.05 t over 0.05. So this is the uv portion. And then we want to do the minus integral of v du portion. So it's going to be minus, well, du is just 1 dt, so we don't have to um, plug that in. But we have a negative e to the negative 0.5 t. Then we just take this dt here. A little simplifying, put this negative in front. E to the negative t over 0.05 minus. I can take this point and this negative out, so it'll actually become positive 0.05 integral of e to the negative 0.5 t dt. Keep writing it, and then I'll actually just duplicate the same idea here. You want to take the integral of here, of this, so it's basically this. It's negative e to the negative 0.05 t over 0.05. Okay. And then now after I took the integral, I need to I need to evaluate them. And so I'll get something like negative, or actually, what might be easier is I do this so I don't forget anything. But we need to take this and then subtract. So I basically just feed the equation over, and then we want to change out the bound. So here, and I'll do it in a different color. I have 20, 20, 20. And then here I'll have 0, 0, 0. Okay. So just from evaluating, I get negative 120 e to the negative 0.05 uh, times 20 is actually just 1. So e to the negative 1 over 0.05 plus 1.0.05. This is the same thing. So it's minus e to the power of negative 1 over 0.05. Okay, this red negative. But let's see. So this actually becomes 1. So this is just negative 100 times 0.05, 1 over 0.05, plus 1.01 over 0.05 times this becomes 0, I mean 1, so negative. Keep simplifying. Well, I have this 120 120 divided by 0.05, which is negative 24,000 times e to the power of negative 1, which is 882.9 plus I have 1 divided by 0.05 squared times negative e the power of negative 147.15117. And all of this has to be subtracting by this whole number. 100 divided by 0.05, which is 2000, plus or minus 1 and so 400. Okay, so finally, I'll just do, oh, okay, I'll just do that as a calculator, and then I'll do the um calculator ready portion after. 0.15177 plus 2000. And then basically I'm inputting it into a calculator now, but I'm doing plus. This turns into plus. Okay, so I get 3135757. Okay, so this is the rounded answer. So actually, I wanted to give it in million, so 3135758 million. Okay. But now they also want you to do a calculator ready answer. And what that basically means is you need to evaluate this one and kind of simplify it by hand fully. or not fully, but just until you have only a few terms left. So I'll show you what that looks like. I know that this is 2,400. I know that this is 400. So I have that. So I have plus 240 plus 400. That basically is because I distributed this negative. But then I get plus 2, 8. So this is fully simplified. Now let's deal with this one. Well, you see, I have this coefficient 120.5 e to negative 1 plus a 1 over 0.05 um, minus e to the negative 1, 0.05. So actually, because I wrote it in a way where I can have this one and this one be kind of similar, um, you can combine, you can combine, you can kind of do a common denominator. So I need this one to be just like this one. So I'll multiply by 0.05 on top and on bottom. Now I have this. I have minus e to negative 1.05. And I actually just write 0.05 squared. Just what these simplified to. Then, well, I have here I technically have one copy of this e to the negative 1, but here I have negative 120 times 0.05. So that means 120 times 0.05. This is 6. So negative 6 e to the negative 1.05 squared minus 1 e to negative 1, 0.05 squared. So I get negative 7 e to negative 1 over 0.05 squared plus 200, 2,800. This is the answer. So yeah, this is the calculator rounded version, and then this is the hand simplified version. Okay, so now I'm going to do number 6. And I know the professor set up this problem, but I'll just show you how to set it up just to build the intuition. So it says Norman works as a part-time consultant, but is looking to retire and gradually reduce his work hours over a 5-year period. He currently earns 75 per hour, and the market rate is increasing by 6% continuously compounded annually. Currently, he works 1,000 hours per year, but he will decrease his work hours linearly until he leaves the job in 5 years. How much will he earn from consulting over those 5 years? So we need to know is we need to think about the we need to think about well, first of all, we're trying to solve for the total total value. So it's just the integral from 0 to t of r dt. Now we actually need to figure out what this r of t is. They gave us two pieces of information. The first one says that, well, Norman works 75 hours and the market is increasing by 5% continuously compounded. So continuously compounded means we are talking about e and an exponential. So we can say that 75 times e 75 times e to the 0.05. And then we want to figure, and then we need to multiply this by this other function because this, it's basically saying that the market rate or the amount of money is going up, but he's also cutting his hours, so the hours is going down. So we need to multiply these two numbers together. This is kind of the income stream. And so the additional information is that it says that he works 1,000 hours currently. And so currently it's 1,000 hours, but then he will decrease his work hours until he leaves the job in 5 years. And so and we're also given the information that this decrease is linear, which means that we can expect something to look like this, where he starts at 1,000 hours and keeps decreasing. And then when it gets to or when it gets to 5 years of working, the hours will perfectly hit zero. And so what does that mean? It means that we have an x-intercept, x is equal to 5, y is equal to 0. We need this point to lie on our graph. So we need to solve for the function that represents this kind of decrease. And because it's linear, we know it follows the form y is equal to m t plus b. And here in this case, I replaced the usual x with t, but it's just t as in time, and it's the same. You treat it the same as if you were to treat x. But basically, we have that he starts at 10,000 hours, so we know that b is 1,000, and then we need to solve for the slope. But we also have this additional point, so I'm just gonna plug in y. I'm gonna plug in. Sorry, this is supposed to be like this. I'm gonna plug in 0 is equal to m times 5, 1,000. And then what do I have? We have negative 1,000 is equal to m times 5. M is equal to negative 1,000 divided by 5. And that's exactly what the professor wrote. So then y is then equal to negative 1,000 over 5t plus 1,000. So this is second, our second function. And to put it all together, we need to set an integral. Income stream is actually the product of 75 e 0.05t times negative 1,000 over 5t plus 1,000 dt. And then just in this case, it's a 5-year period. So we would integrate from 0 to 5. Other thing that your professor did is just to make this integral simpler to evaluate, we want to take out as many constants as possible. So I have an 1,000 here. I kind of have an 1,000 here, and then I have a 75 here. So I'm going to take out, and so all of these are multiplying by each other. So I can rewrite this as 75 e to the 0.05t. And then I can actually rewrite this second part as times 1,000 negative t over 5 plus, and this is exactly what the professor had. But now this is kind of what we do to take all the constants out to make the integral smaller numbers. This is the final integral that you have to evaluate. 1 minus 2 dt. Okay. And so this integral is not that easy to do. It's because it's an integration by parts, but we can just solve it anyways. We let u is equal to 1 minus t over 5. du is then equal to negative 1/5 dt. Let dv is equal to 0 e to the 0.05t, and v is equal to e to the 0.05t over 0.05. And then well, we want to set up, so, well, we won't forget about this constant in front. You have 1 minus t over 5 e to the 0.05t over 0.05 subtracted by integral of dv du. So it's negative 1/5 times e to the 0.05t, 0.05 dt, something like this. Then keep simplifying. And then, by the way, you have to add these boundaries, these integral bounds, but sometimes I just don't write them. But just as long as you don't forget them, I think it's fine. We want to then evaluate this integral. I'll just rewrite this all from 0 to 5 minus, and then let's do this other side now. So I have one negative here, one negative here. So this becomes a plus 1/5 integral 1/5 times 0.05, something like that. Integral of, so I rewrote this as plus integral 1/5 integral of times 1 integral of e to the 0.05t dt. And then you just take this integral, something like this. This is the integral. And then you obviously need to evaluate this one as well. Now it's sort of the easier because of this, and then I'll just write it. 1 minus 5 over 5 e to the power 0.05 times 5 over 0.05 plus 1 over 5, 0.05 e to the 0.05 times 5 over 0.05. And then this all needs to be subtracted by 1 minus 0 over 5, which is just 0, e to the power of 0 over 0.05 plus 1 point times 0.05 times e to the 0 over 0.05. And then something like this. So this is after we plug in that. We need to make sure we include the 75,000 as well. Well, here we have, as we keep simplifying, I'm starting to simplify this part now. 1 minus 1, which is awesome. It just zeroes out. And then I have 1 over 0.25 e to the 0.25 over 0.05. And then minus, well, this one zeroes out. This is just 1 over 0.05. So we have 1.0.05. And then here we have times 0.05 times 1 over 0.05, which is kind of just 1 over, it is 5 times 0.05, which is 0.25 times 0.05. So it's a very similar situation to this case. Okay, now we keep simplifying. So, well, I have e to the 0.25 over 0.25 times 0.05. I can actually subtract this one because they have the same denominator. I can subtract e 0.25 minus 1 over 0.25 times 0.05 minus 1 over 0.05. And from here, I'll just plug it into the calculator. If I plug it into the calculator, I get e to the power of 0.25 minus 1 divided by 22.722 minus 1 divided by is equal to 2.72. This is my answer. And then this is the answer. Um, this is the answer. Uh, I'm trying to check with the answer key, but I can't find this question. So we'll just keep this one for now, and then I'll check it. Sure. Okay, the next two are the differential equation problems. I'm gonna do the first one just so you can have the simplifying on hand, but well, I look at this differential equation and I see this x times y, so I immediately think it's a separable equation. And what is then you kind of like you want to split up the integrals because you can't take an integral with two variables at once, especially not for differential equations, because the y is technically a function still. And so all you want to do is you want to split up this integral. Well, I need to break it up into its factors. So let's first divide the x squared plus 1 over. dy dx is equal to x times y over x squared plus 1. And this is just after me dividing this to this side. Then from here, I have two distinct variables. I have x squared plus 1 times y. And then now we need to figure out a way to split this up into two integrals, one with respect to y and one with respect to x. And so let's do cross multiplication. So we'll do it like this. X squared plus 1 times dy is equal to xy dx. So we're almost there. We notice that this y is with the dx and this x is with the dy, but we just need to switch them around. So put this y over and then this x squared plus 1 over. So it's 1 over y dy is equal to x squared plus 1 dx. Okay. And now we notice that the only thing we have is this dy dx, and this is technically the notation for derivatives. When we get rid of derivatives, we take the integral. So as long as we take the integral of both sides, we can solve for this y. Because the goal for differential equations is always to solve for y or f, always to solve for the original function. And so we can evaluate these two integrals separately. This is ln of y, And note here that I didn't forget about this, the plus c that I do with an integral, but the important thing to notice is that whenever you have differential equations and you're evaluating two integrals, you don't really need to add two plus c's because plus c is very general. Like if I added plus c and then I took the integral here and then added plus c, I could add, subtract, and then it would just turn into another, like a different version of a plus c. So it's plus c just means plus a random constant. And so it doesn't really change anything. But for the next side, to evaluate this integral, we have to do a u substitution. So let u is equal to x squared plus 1, then du is equal to 2x dx. Then du over 2 is equal to x dx. Okay, so then you just perform the u substitution. As long as I plug in du over 2, I can substitute it. So I'll just do 1 over u times 1/2 du, something like this. And then I have equals ln 1/2 ln of u c, and then I added plus c back. Um, we need to plug in the u again, so x squared plus 1 plus c. And then final steps, we need to solve for this y. So how do we solve for y? We need to isolate it. And the only thing stopping us from having this y is this natural log. So we need to take the inverse of natural log, which is e. So we've put both sides to the power of e. So this actually cancels out. I'll just get y is equal to e to the power of 1/2 ln x squared plus 1 c. Um, this is totally fine. This answer is totally fine. But if you want to go a step further, and sometimes professors do, you can notice that this is e to the 1/2 ln x squared plus 1 times e to the c, the property of adding exponents. And notice here, e to c, like I said before, c is could be any constant. And so we could just replace this with a different constant. So this is the final answer. And then obviously you could do more simplifying, but I don't think that's necessary. I think this is fine. This one or this one. So that's how you solve the first one. Okay, now let's solve the second one. The second one is not obvious. Actually, let me see. Let me double check that I have the problem correctly. Continuing the second problem. I just had to double check that this was correct. But the problem is dy over 2 dx is equal to xy plus 3x minus 2y minus 6. So at first, this is um completely unclear what this problem could be. But given that there aren't that many so far, there there you haven't learned that many differential equation solving techniques. We can either think about separable equations, we can think about other one where you just have function with y, or you can think about the basic one. This one would, the best guess is a separable equation because we do see this x times y again, but it's just not clear what this has to do. And this definitely comes from experience, but we have to notice that this is something that you can factor. Because if you notice here, I have a x times a y here, I have a x term, a y term, and a 6 term. So it's very true that you can do something with this. And so we just want, we need something to multiply to -6 to be in these terms, and then multiply with x to turn into 3 and multiply with y and turn into -2. Well, what term multiplies with x? It's this one, so we need this to be a +3, this one to be a -2 because, and then just to prove it to you again, this one multiplied is xy, this plus 3x, this one multiplied together is -2y, and then -6 is the last one. So it does turn out to be equivalent. And now we have separable equations function. And so let's do that again. We need to divide and then we need to kind of cross multiply again. So I only have, I'll just actually divide this 2 over. So dy over 2 dx is equal to, or dy is now equal to x minus 2, y plus 3 times 2 dx, something like that. And then, well, this 2 is kind of like, it could be on either side. It could be a constant, it could be a constant for x, it could be a constant for y, so it doesn't really matter. But I'm just gonna keep it with the dx though. And all I need to do now is take this y plus 3 and move it to the other side because that is the only thing preventing me from taking the integral. So dy 1 over y plus 3 dy is equal to x minus 2 times 2 dx. And then now we finally need to take the integral of both. And then I'm just factoring out, multiplying this 2 out. Okay, so let's focus on this side first. It looks to me like it's going to be a u substitution. So y plus 3, then du is 1 dy. And so 1 over u dy. Then this is just ln of u, which is ln of, this is the answer for the first side. Then this is a pretty simple integral, so it's 2x squared over 2 minus 4x. And that's, then we just need to do a plus c as well. So we have this is equal to 2x squared over 2 minus 4x plus c. Okay, now final step, we need to still solve for the y. So just like always, we want to take the inverse of natural log, which is e. So we get y plus 3 because these cancel out, and then e to the all to the power of x squared over 2, which is just x squared, minus 4x plus c. Then y equals to e x squared minus 4x plus c minus 3. And you can do it further and say this is equal to e to the x squared minus 4x times e to the c minus 3, which is just y is equal to, let e to the c equal constant a, and this will be your answer. And so this is the second answer. Now let's do the next problem. Let f of x be a Lorentz curve if f of 0.6 is equal to 0.3. Is it possible that f of 0.7 is equal to 0.28? Okay, so in order to answer this problem, we have to really understand what the Lorentz curve is. The Lorentz curve is basically a function that describes the x value, which is the population percentage, So it actually goes from 0 to 1. And then it tells you for when you plug in the population percentage, what percent of wealth does that correspond to? For example, we might expect like if we have 30% of the population, maybe we can expect that percent of the population might have 25% of the wealth, and so on. And so now let's go back to the question. It's saying that if I have f of zero point 0.6, which is a probability of zero point 0.6, so this is saying zero point 0.6 or 60% of the population has zero point 0.3 of wealth. And it's asking you if that is the case, is it even possible that I can have 70% of people have 28% of the wealth? Well, this is definitely not possible because we need to think about the Lorentz curve as always increasing. And if you have a zero point 0.6 population percentage, that corresponds to zero point 0.3. It's looking something like that. And then when you have a zero point 0.7, it's going down actually. And that doesn't make sense because it's saying that 60% of the population has 30% of the wealth, but then once you get to 70%, that 70% goes down to 28% of the wealth. It doesn't really make sense. And so this is not possible. Okay. Now let's answer number three. This is a very similar question, but it's just asking for one value. And so we can sort of suspect like something like this. We want to say that for zero point 0.2 of the population, is it possible that they have zero point 0.3 of the wealth? And the answer is yes, it totally is possible. And we can actually even give an example. So we want an example of it such that when I plug in, I want to solve for the Lorentz curve, and the general form is x to the power of p, where p is just an exponent. And I just need to find p such that when I plug in zero point 0.2, so x is equal to zero point 0.2, I get out zero point 0.3. So you say zero point 0.2 to the power of p is equal to zero point 0.3. Well, I can take the natural log of both sides to get the p down. Natural log of zero point 0.2 p equals natural log of zero point 0.3. And the reason why I take natural log is because of that rule where it says the exponent, if you have a log, the exponent, it's equivalent to saying p times 1.2. It's equivalent to saying p times p to the power of p. Ln 0.2 to the power of p is the same thing as p times ln times zero point 0.2. And then same, and then on this side. So now you can just kind of solve for p. So p is actually this. And then if you want to plug it into the calculator to get p is equal to 0.74. And so we can say, yes, it is possible for f of zero point 0.2 equals zero point 0.3, take of x is equal to x to the power of 0.748. And if we take that, then we'll just have that when I plug in zero point 0.2, I'll get out zero point 0.3. And so that is the answer for number three. Now let's do the next problem for Gini index. It's called working backwards. So we actually have done problems like this before, but let's just take a look at how to do it. So it says the CIA website reported that the Gini index for the distribution of family income in the US was 0.32. And so for part A, we want to assume that the Lorentz curve for this distribution has a simple form of f of x is equal to x to the power of p. Determine the p that matches the given value for the Gini index. So let's write the Gini index equation first. So we'll have gi is equal to integral 2 times the integral of x minus f of x dx, and then bounded by from 0 to 1. So this is the Gini index. Okay. And then, well, I don't have a specific f of x, so I'm just going to plug in that general form. But I also have a 0.32, so I can plug in that information as well. So 2 times 0 to 1, x minus x to the p dx. This is nothing more than just like an integral. So to evaluate this, I would just do like the basic x to the power of 1 plus 1, and then over 1 plus 1. And then here you want to use the general form. So x to the power of p plus 1 over p plus 1. This is the general integral form. And then keep going, keep simplifying. 2 times 1 half minus 1p plus 1, and then plus 1 minus, and keep in mind, because there's two variables, it might be confusing, but integrating with respect to x, so your bounds need to be plugged into the x and not p. And then you subtract it by 0 minus 0. Just that. Okay, keep going. It's 0.32 is equal to 2 times 1 half. Well, I know that 1 to the p plus 1. Well, 1 to the power of any number to the power of a, 1 to the power. It's always just going to be 1, so I don't need to include this p plus 1, so I can just do 1 over p plus 1. And then I want to eventually isolate this p, so let's divide this 2 to the other side. So divide by 2, divide by 2, I get 0.16 is equal to 1 half minus 1 over p plus 1. And then I can subtract the 1 half. So 0.16 is actually equal to 16 over 100. So, and then minus 1 half, which is 50 over 100, equals negative 1 over p plus 1. This is just uh, negative 34 over 100, I'm pretty sure. Okay, yeah. And then equals to 1 over p plus 1. And the negatives cancel out. I get this. Cross multiply. 34p plus 34 is equal to 100. 34p is equal to 100 minus 34, which is 34p is equal to 66, I think. Yeah, 66. Then p is equal to 66 over 34. So you just take p is equal to 66 over 34, and your f of x is equal to 66 over 34. And you can simplify it to x is equal to 33 over 18. Okay. Now part B. Part B asks, according to this model, how much of the family income is earned by the top 2% of families? So we can imagine this to be the Lorentz curve. We have something like this, where we want to figure out, okay, this is the top, this is 98% of the families. We need to figure out this difference from 98 to 100% of the family. So we need to figure out 0.98 and then subtract it by 1. So it's just 1 minus 0.98 33 over 7. So I get 0.0384. And then this is roughly 3.84%. So, and if you think about it, that's pretty good because it's just saying that 2% of the family has 3% of them, which is not bad of a distribution. A diagram here. Basically, for the first problem, we need to find the total income earned by the top 10%. So we need to find the 90% first and then subtract it by 1 minus f of, which is 90%, which is 1 minus 1/4 times 0.9 plus 3 over 4.9 to the 4, something like that. Okay, so it's this is 0.25, 225 plus 24 plus 0.492075. This is 1 minus 0.717075. 1 minus. So I get the answer is 0.282925. So it's 28.2925% up. Okay, so this is the first problem. Now let's find the Gini index. So the Gini index is really standard. You need to do 2 times 0 to 1, x minus f of x dx, something like that. I'll just plug in all of the information. X minus 1/4 x plus 3/4 x to the 4th dx. And then 4x to the 4th dx. Okay. So 2, 0 to 1, x minus 1/4 x minus 3/4 x to the 4th dx. 2, 0 to 1. This is 3/4 x. If you combine these, it's 1 minus 1/4 for the coefficient. So you get 3/4 minus 3/4 x to the 4th dx, which is just 2 3/4 x times 1/2 x squared minus 3/4 times 1 over 5 times x to the 5th from 0 to 1. I get 2 3/4 times 1/2 times 1 squared minus 3/4 times 1/5 times 1 to the 5th. And then this is all subtracting by zeros. Doesn't make a difference. You just need to simplify this now. Well, I have 3, this is 3 over 8 times 2 is just 3 over 4. And then this is actually just 3 over 20 times 2 is just minus 3 over oh, you get that the answer is 3 over, well, we have to do a common denominator. I'm gonna do of 20. So it's minus 6, and then this is 15. So I get 9 over 20 is the Gini index. Okay. And then finally, let's do number 6. So suppose 87% of private land in California is owned by the top 5% of the population. If the Lorentz curve has a formed bit of x to the power of p, find p, then determine the Gini index for private land in California. So we need to say that point that 87%. So we need to say that 87% of the private land is owned by the top 5%. So it's an equation like this. Whenever you hear top percent or top something percent, you just think 1 minus 1 minus the 1. So point. And to get this, I just say, well, I know that 5% refers to 0.95 minus 1. And so that's kind of what this is the, okay. So this is 1 minus f of 95. And it's saying that this is actually just equal to 87% of the land because this is the top 5% is equal to 0.87. So we need to figure out 1 minus f of 0.95, which is 0.95 to the p, because f of x is equal to x to the power of p is equal to 0.87. So let's do some basic algebra. I get that this is negative 0.313. The negatives cancel, so I just get this. I want to take natural log of both sides to get the exponential down again. And then my answer is ln of 0.13 over ln of 0.95, which is equal to 39.775. And it makes sense because we are talking about the top 5% of people owning 87% of the private land. So we can expect that the curve grows very steep. Okay, but now that we have this, we have that f of x is equal to x to the power of 39.775. And so let's find the Gini curve. I mean the Gini index. The Gini index is 2 times 0 to 1 x minus 39.7755 dx. And so this is besides the weird exponent, it's very straightforward. I'll just do, this is 40. You just still add 1, right? So this is what you get from 0 to 1. This is 2, 1 half minus 1 over 40.7755 minus 0. So this is the answer. 1 minus And then I get that this is equal to this. So 1 minus that is 0.97547. And this is a pretty bad Gini index because it's saying that uh, because a good Gini index would be 0, a bad Gini index would be 1. And this is pretty close to 1. So